Hi, my name is John Dee. I'm Technical Director of Global Energy Options Proprietary Limited, the owner of a product, a special lubrication product. The purpose of my sitting here with this brake test machine today is to demonstrate the difference between a high quality lubricating oil with its inherent additive package and adding 6% of our product to such an oil to produce significant improvements in mechanical efficiency. The machine here is designed by Falix Corporation of the United States, who provide a lot of test data for corporations related to mechanical engineering. This unit has a rotating Timken 93 Rockwell hardness bearing, and we're going to apply a pressure via this fulcrum arrangement to the bearing using a roller bearing as our wear material. I need to be very careful not to contaminate the initial test with our product, otherwise this bearing will be treated and the normal oil will perform in a way that it never has before. So we've carefully cleaned the machine since the last testing. I'm using this as a sump. The sump mounts on here, and we'll add the lubricating oil to this sump. I'm going to use a new unopened bottle of the product. It seriously is unopened. I'll now add a roller bearing to the mechanism here, and put it in place. When I turn the machine on, you can see the oil running on the bearing, and you can imagine this fulcrum providing pressure for the bearing onto the Timken bearing. I'll add weights, and we can also see the electrical supply that's been required to drive the mechanism. So I'm going to gently lower the bearing without any weights onto that location, and then I'll add weights slowly one at a time. You can see a slight increase in the current, but not much at this stage. The lubricating oil is doing a fairly good job. You can hear the sound increase slightly, the noise on the bearing. And the current is going up about 10% with each. And with 6 or 3 kilos, we've stalled the machine, so I've taken the weight off. That is 36 times mechanical advantage with this system here. So what we had 3 kilos 36 times, so it's about 100 kilos on that point. I'll now add a small amount of this product. I won't bother to clean out the iron filings that have been left from the scoring of this bearing, which I'll show you more closely later. I must remember to rotate this bearing so that the new scar with our product will be in a different place on the bearing. So normally we would add 6%. In this case, I won't measure it, I'll just add a couple of drops. But it wouldn't make any difference whether you added 3 or 4 drops in here or into engine oil, 6%, which is normally used, but if it was more, it wouldn't make any difference to the operation of the mechanical system, including engines. Now I'm going to take the weights off this unit and add them again in the same manner. The current is just marginally above what normally the standing current is with no load. Didn't realise I was going to need more weights. Weights on there. I think it's ran for about the same time as the other one did. We could. You might have heard that suddenly the sound changed, and the reason for that is that the temperature on the wear positions has gone up considerably, and so more effective treatment has occurred. And now we're running with less noise, mechanical noise, than we were at the start when with just the mobile oil. You can actually see smoke here because we've got such a high degree of friction with this incredible weight on this point load on this bearing that the oil is actually evaporating.
John, last time when you said it was the pressure was 100 kilos, then how many kilos is this pressure?
Okay, so it's 360 kilos. So we have over 3 times the weight, we have less wear on that bearing. So because we put the wear just on one bearing, we need to To show you the two bearings together, I'll bring one that was done previously. So this is the original bearing that we just used, and these were two trials showing the wear in the left with 3 weights, and on the right hand side with the same with 3 weights. So they're equivalent wears on the bearing, and this one here, I think if I can find it, shows the wear with nearly 4 times the weight. So the wear area is smaller, but the weight was 3.6 times the original. And the energy required, the electricity required to drive the system was considerably less. The biggest advantage of this product is in harsh environments. We could have sand, iron filings, anything in that oil, and the product itself, because it changes the molecular structure of the surface of the ferrous metal, it makes it smoother and denser, so any foreign bodies in the oil tend to slide off the area where the two metals are coming together. That's the demonstration. Thank you very much.